Hello students, now let us look at the third and the final part of the packaging of DNA. Okay, let us see what you want to see in this module. Fine. Now remember, at higher levels the packaging is slightly different because there are no histone proteins involved here. Is it okay? Now in higher level, packaging requires an additional set of proteins, and these proteins are called as non-histone chromosomal proteins. They can also be abbreviated as NHC proteins. Just let us see how these NHC proteins kind of look like and why they are called non-histone proteins. Okay? Now look, if I take this chromosome and if I try to peek in the chromosome, what will I see? I'm going to see my chromatin loops and see how they look like. They are lovely, almost look like a flower. Is it okay? Yes? So you can see there are going to be many such chromatin loops in your chromosome, okay, that will wrap itself up like a flower, yes? And then to join these different chromatin loops, you will need a protein, which are non-histone chromosomal proteins. And how will it join them? Look. Wow, did you see that? Now that is one protein which is joining the chromosome loop, which is not a histone protein. Okay, what are these loops called? These loops are called as rosettes of chromatin loops. Is it okay? Because they appear like flower. And the protein that is connecting them and keeping them together are called as non-histone chromosomal proteins, also called as NHC proteins. Is that okay? These proteins have another name. They're also called as scaffold proteins. Is that okay? Moving on. Now let us look at the chromosome again. You remember this chromosome? You just saw in the previous module as well as the previous slide. There are certain areas on this chromosome. Look carefully. Do you see certain areas that are light while others are dark? Yes, you do. Now that's one area I've highlighted up there as a light area. And this light area is called as euchromatin. The other area pointing here is called as the heterochromatin, and it is kind of dark. Okay? Let us see what is the main difference between euchromatin and heterochromatin. Look at a diagram I'm going to show you here. Look at the euchromatin. You see that? You see that's a packed DNA, and you see how loosely it is packed? Is that fine? So I can say that euchromatin shows loosely packed region of chromatin, where the DNA is loosely packed. Is that okay? Heterochromatin, on the other hand, looks slightly different from euchromatin. And how is it different? Look at that packing. What do you think that packing looks like? This packing looks as though it is tightly packed. Is that okay? So I can also say that the heterochromatin is the tightly packed region of chromatin. Okay? Now because the one euchromatin is loosely packed compared to heterochromatin, which is tightly packed, euchromatin is going to stain light when I use chromosomal stains. And that's why in the picture I've shown you certain light bands, because that light band indicates it is a loosely packed region of chromatin called as euchromatin. The heterochromatin, because of its tight packing, will stain dark when I use chromosomal stain. And that's why you can see in the picture above that the heterochromatin region has a darker stain there. Is that okay? And that is how you can differentiate between the two types of chromatin. One stains light while the other stains dark. Finally, the main difference between the two types of chromatin is the fact that euchromatin is transcriptionally active chromatin, which means it will take part in the process of transcription. Whereas heterochromatin is a transcriptionally inactive piece of chromatin. Is that okay? Which means it will not take part in transcription. Now what exactly is transcription? If you remember from my previous modules, that transcription is a process by which DNA will give you RNA. Is that okay? So this is possible only for euchromatin because it is transcriptionally active. It is not possible for heterochromatin because it is transcriptionally inactive. The details of transcription we'll be looking at in the future modules. Is that okay? So here I've listed few differences between euchromatin versus heterochromatin. This brings us to the end of packaging of DNA, part 3. And the next module, I'll be talking about yet another type of nucleic acid called as RNA or ribonucleic acid. Thank you and take care.